So there's a friend of mine in the audience, and he learned something right now, which is interesting. All right. Hello, everybody. I hope you have a good day. Let me tell you how I came into the web. I have the luxury that my father was a very tech-savvy person, so I was one of these people that had an internet connection in a very early age, and we're talking pre-Google, right? Where you just entered URL and saw what came up, right? So I was a little bit lost by the time, I feel like everybody, but in Europe what happened then was that first social networks appeared. So what you see there is ubo.com, which translates to submarine in English. And I kind of saw myself hanging out in the net more and more and more, right? Because I was chatting to different people, which was fun, right? I was 12 or something. And there I was, in the middle of Germany, 1999, living in the middle of nowhere. So honestly, when you see Germany, right upper corner, there's nothing. And I was talking to people in Berlin because we shared some common interests, like music, yeah, it was mainly music, because I was playing in these several bands, right? And this was for the first time when I figured out that the web connects people. And then I became a sound engineer, and I worked for several TV stations, but I found out that working for TV feels glamorous, but it is not. And I became a web developer at some point. And then the whole statement, the web connects people, changed actually to we connect people. Because I now have the superpower to build for the web. We enable people by building products that help people in certain situations. And yeah, we help people. So let me quickly introduce myself. I'm Stefan. I work for a company called Twilio. So if you wonder how you can send SMS, make phone calls, and all these kind of things in your applications, you can check that out. And the most important thing, though, is that, hey, I'm Stefan, and I want to be a responsible developer. So when we look at the global population today, and where I was coming from, 1999, there, really nothing there, right, remember? We can now have a look at some statistics. And when you look at internet statistics, you will find out that the most internet users actually come from China, from India, and the United States. And this is common statistics when you deal with these kind of topics. But I also run a blog, right, and I write everything down. And just last month, I had 300 people from Brazil reading my articles, 100 people from Vietnam, and 80 people from South Africa. I'm very excited about this, right? It's just not that many people, but think about it. Someone in South Africa reads my stuff, which is very, very cool, but at the end, it really doesn't matter because we should be building for everybody. Ta-da! And I'm doing web development now for almost 10 years, and very often, especially when responsive web design came up for the first time, we had these statements. We don't have users that use a mobile phone. We don't have users that have a slow internet connection. We don't have users that do or are in a certain situation. And basically what happens when you say that statement is that you're creating a chicken and egg problem. So guess what? When you build a website that doesn't work on a mobile phone, that doesn't work when the person has fast internet, then these people won't use your stuff. It's as easy as that. Building a good website today is very, very hard though. You have to consider a lot of things. So you have to think about design and colors and all these things. Did you know that green and red, the meaning of them is inverted in some Asian countries? So that red is something good and green is something bad? Ship globally, right? Good luck with this one. You have to consider good content. Your stuff has to be fast, because when it's slow, people won't use it. It has to be accessible, because some people use assistive technology like a screen reader to access the web. I'm a JavaScripter. You have to figure out what to use. I don't know. You have to optimize the network stack, and you have to make it work across several devices, and there's much, much more to the topic. And in the next 40 minutes, I want to talk about the network stack. So let's talk about HTTP. So when you're requesting a website, what happens? You make a request to this website, the responsible.dev. And yes, I had to buy a .dev domain because it was trending 6 months ago. And what the browser then does is that it sends a set of key value pairs called request headers. The server then answers with another set of key value pairs called response headers and with the resource that you're actually requesting. So we're talking here about request and response headers. So I know you're very curious to see what is behind the responsible.dev. So let's have a look. So here you see the responsible.dev, and you see a normal website, but you already see that JavaScript is disabled. So what happens when you now enable JavaScript? Well, there's a permission dialog, there are unicorns, and also I can go to CodePen, and I can frame the site, and I can pretend to be the responsible dev, but I'm actually not. So, and I can click-check stuff, and overall, the responsible dev is not in a very good shape. How can we use this? How can we use headers to make this site better? Overall, I think that the web today is a very, very scary place. Just a year ago something, this was big in the news, and maybe you have heard of it, but there were thousands of websites mining cryptocurrency in the browsers of their users, and the site owners didn't know about this. Think about this. How can you not know that someone is mining Bitcoin in your website? Because a third-party script was hacked. Then there's this very old podcast episode by Chris Coyer and Shop Talk, and it's very old, but it's so good. There was one person that social engineered their way into the CDN that hosted the global jQuery. Think about that. A hacker has access to the global jQuery. You can mess up the whole world with this. Or just a few months ago, there was the event stream accident. So event stream is a very popular NPM package. And what happened is that the maintainer was fed up by the package and was not maintaining it anymore. Then a random person showed up and was like, hey, need help with this? And when you do open source, you're obviously like, yeah, I need all the help I can get. So what happened then that this person got access to the package, which is very popular across the Node ecosystem, and started scanning the computers of the people for Bitcoin wallets. Bum, bum, bum. The thing is that when we do web development, we always rely on others. And the web has to be safe because we have to trust we cannot trust everybody. And the first thing that we have to do is we have to think about HTTPS. Without HTTPS, what happens is when you're sitting in Starbucks and you go into an open Wi-Fi network and you open a site over HTTP, you cannot be sure that someone is messing with you and the site. So HTTPS basically blocks man-in-the-middle attacks. This is not possible anymore. And browsers also are pushing for HTTPS adoption because features like HTTP2 and service workers are only working over HTTPS. So there's a site out there that is called Why No HTTPS, and it's not 100% accurate, and it's pretty good. So Canada does a pretty good job there, so I didn't find a big site that is running over HTTP. But I have a German example here. So ARD is a massive German media outlet, and they're shipping over HTTP. So people can just pretend and sit in the middle, depending on the network stack, and this is highly insecure. And also, media outlets also ship with a lot of third-party scripts. So if you want to figure out what scripts are included in a website, what you see there is request.map.webperf.tools, which visualizes all the requests that are included in a site. So you should go for HTTPS. But then there's the thing, how do you ensure that you always ship over a secure connection? What you can do is, you can set a strict transport security header. You can define how long this should be active in seconds. And this basically tells the browser, whatever happens, this site will not work over HTTP. It will only work over HTTPS. You can include subdomains, and you can go the adventurous route. You can set a preload directive. When you set the preload directive, what you can do is you can go to this visually appealing site, which is called HSTS preload, And you can submit your site to be included in a global registry of sites that work only over HTTPS. So what you see there is this file that is included in the Chromium source, but it's also spread across browser vendors. Basically, it's a big list of sites that shouldn't work over HTTP. In case you ever wondered why you cannot use .dev domains on your local machine without HTTPS anymore, this is the reason. .dev domains are included in there. But HSTS is not only about security. What happens when you type an address in the URL bar? The browser by default will make a request to HTTP, which depending on your connection can take a lot of time. When you have HSTS enabled, you can skip this first request, which maybe delays 2, 3, 4, 5 seconds before you actually hit or see what you typed the URL in for. So how's the support for HSTS? We're all green and you can use that today. You have to be very careful though, because your certificates have to be bulletproof, because when you have set HSTS and you mess up your certificates, then basically you're more or less down. So now you're switching on HTTPS, and maybe you have a big sites, thousands of sites and assets linked in this site. How do you upgrade all these HTTP requests? Because now you get mixed content warnings, because you're running on HTTPS, and you have HTTP requests everywhere. What you can do is, you can set content security policy, upgrade insecure requests, which magically updates all HTTP URLs to run over secure connection. That's magic. This is not the main purpose of CSP, content security policy, though. CSP is there to give you a way to limit what is allowed in your website. CSP is there to avoid that a random script mines cryptocurrency in your browser. So what you can basically do is you can define where images are allowed to be loaded from, what media should be loaded from, what scripts should be there. And there's a lot of things that you can use to secure your websites. There are a few experimental in there, and you can set these as a meta element in the head, or you define a header like this. So this is the header that I run for my personal website. It blocks as much as I can, because this is how CSP should work. And when you start working with CSP, what you should do is you should run in report only first. So what this does is it will not block stuff, but it will rather send reports to a defined URL and will tell you, hey, I would have had blocked this if we would be in active mode. So this way you can make your way through a rule set that actually works. So when you now look closely to my rule set here, you see something that is very dangerous. I have unsafe inline and unsafe eval in there. And the reason for that is that I'm running in a JavaScript framework that has to inline some JavaScript stuff and doesn't have a CSP option right now. I'm working towards to fix this with the maintainers. So when you have inline JavaScript, how you could whitelist certain blocks that you have in the body of your page, you can define a hashed value. This has the problem, though, that now whenever something happens inside of the script block, you have to change the header. So this is a little bit brittle. What you can do also is you can define a nonce property, which then means that you can whitelist certain script blocks, and this can be very handy. So how's the support for content security policy? It's in 2 levels. So level 1, pretty green. Level 2, almost green. So you have to check how this is going. And I took a look at HTTP Archive. For the people that don't know HTTP Archive, so this is this massive website that crawls the internet and gives you the information about how we are actually doing. And then you can use a tool that is called BigQuery to run against this data set that is provided by HTTP Archive. So, how many people have the safety net of CSP enabled? Any guesses? What? 3? 1? All right, The data set of 2,800,000 crawled pages, only 6% had CSP enabled. I don't know how you feel about this. I think we can do better. So overall approach when you deal with CSP, monitor first in report-only mode, test in production, and then flip it over to really block stuff. So what does that mean for the responsible.dev? So I added a new route, which is /safe. And you see there that the unicorns disappeared because I defined a CSP rule, which blocks the malicious script. And also when I go to CodePen, it's not possible to frame the page anymore because the browser will tell me, nope, sorry, the rule set does not allow framing of the certain site. And I think these tiny, tiny things are very important because the web is crucial for people. I hang out on Twitter a lot, and these kind of statements appear more and more in my timeline, and that actually makes me very sad. And it's not only about people in a certain region of the world. I travel quite a little bit for work, and let me tell you what I face very often. So I got out of the airplane, I'm on the airport, my mobile carrier sends me an SMS, tells me how much money I have to pay. So this is now in German. Let's make it bigger. So basically what is written there is, Stefan, welcome to country ABC. You can pay €2, which is, I think, $3 for 6 megabytes, but there's a catch, you have to use it in 24 hours. If you deal with web performance, you can turn on your phone, and it takes you 20 minutes. Then you are done with this. Because the average website today is 2 megabytes. But you have to use it in 24 hours. If you're interested in these kind of things, what I find very interesting is to get data about people and what kind of situation people are in. So what you see there is, what does my site cost? And this site gives information about what data costs in a certain amount, or in a certain area of the world. So what you can do is you can enter your URL there, and you will see, okay, my website would cost someone living in this area of the world that amount of money. And I think this is very, very nice information, because when I'm blogging and writing technical articles, I'm shipping basically for everybody. So it is good information to know what my website costs in different areas. Because the web has to be affordable, and there are several things that we have to consider when we're talking about affordability. The first thing is don't request the same content over and over again. And there are only two things in computer science that are hard, right? Naming things and cache and validation. So let's talk about caching very briefly. So what you can do is you can set a cache control header. You can tell, hey, browser, please keep this resource in your cache for a certain amount of time. Just because you define this header doesn't mean, though, that the browser doesn't make any requests. Because browsers also revalidate if the resource in the cache is still fresh, or if it should be requested again. For stuff we do in the front end, though, what you can use is you can use the immutable directive. What this directive does, it's basically telling the browser, never request this again. Because what we do usually is we ship CSS files, for example, like styles.somehashvalue.css. When there will be a new file or we update something, it will be a different file. There's no need to revalidate if this CSS file is still the right one, because it cannot be, because otherwise it's a different file. So you can check out the immutable directive for that. It is a little bit on the edge, but we're slowly getting there. For the whole picture of caching, I can highly recommend this article by Harry Roberts. It's called Cache Control for Civilians. Caching is hard, and the cache control header is very complex. So have a look there, because there are different directives like no store, no cache, must revalidate, or stale while revalidate. You can configure a lot of things with this. So it's about saving requests, but it's also about sending the right data. So when the browser makes a request for some HTML, what it basically does, it sends this header, except encoding. And you see there gzip and Brotli, so stands for BR. So I had a look. Let's assume we have a style sheet that is 100K heavy, and let's gzip this. We can shrink it down to 15K with gzip. But look at this. Brotli compression is 10K. That is way smaller than the gzip alternative. So why are people not using this today? Because the main mantra in our industry is, Stefan, Brotli compression is so slow, which is basically comparing apples and oranges or apples and pears, as I learned. Different story. So let's let's have a look at gzip and Brotli. So basically it's two different things. gzip has 9 modes. Brotli has 11 modes. And gzip in a default mode runs in level 6. Brotli in default runs in level 11. The main difference here is that the default mode of gzip was chosen for speed, with a relative okay-ish file saving. The mode for Brotli was chosen for file saving, not for speed. This is why we have better file savings with the default mode of Brotli. The thing though is that we now tweak the Brotli settings to level 4. It turns out that Brotli can be as fast as gzip, but it tends to compress better. Which means that you could, for example, when you use Cloudflare, there's just one checkbox where you can tell, hey, use Brotli. And they will compress on the fly, because it will compress better. The thing with Brotli compression, though, is that you don't have to do it on the fly. In the front end, we all do build processes anyway. What if we generate all the Brotli files up front and we get the maximum file sizes? If you want to learn more about compression, the friends at Akamai did a massive research about this, so I can highly recommend that. And Brotli is basically supported everywhere. And it's very interesting because when you look around in the internet and you look at the big players that serve a lot of data, let's have a look at Facebook or Google. They're serving BR, Brotli, because on their scale, a few kilobytes per HTML makes a massive difference. So it's about compression, but it's also the big thing that needs the most data in the internet is tailored or media, right? Images are the majority of the web. So who's guilty of writing something like this? So what you see there is a responsive image with a picture element. I do a feature detection if WebP is supported, and I also ship properly sized images. When you wrote this, you will have discovered that this will break very quickly, because it's actually not easy to maintain something like this. The thing, though, is that when browsers do image requests is that they will actually tell you what they understand. So they send an accept header that includes, for example, hey, I understand WebP, I understand PNG, I understand JPEG, go for it. So when you have a look at the support for WebP, so WebP is just a different image format that tends to be a little bit smaller than JPEG, you could kind of work with this header and serve the proper media. And you then could combine this with the accept CH header. This is a header that you can set on the initial HTML call, and CH stands for clientins. So what happens is that the browser makes a request, you respond some HTML, and you tell the browser, hey, I want to know about your width and viewport width for the next 100 seconds. What happens then when the browser makes a request for an image is that the browser will tell you the image dimensions. I mean, how cool is that? To make that work, you have to define a sizes property on the image so that the browser knows upfront how this image is laid out. But then you get inside of the image request a viewport width and the width header, which means that you can serve properly tailored image without changing any markup. This means when I use this on my MacBook Pro with higher pixel ratio, that I know how big the image should be. I think this is very, very fascinating, and that can be extremely powerful because you can react on the server and the service worker to all the images. Here we are a little bit cutting edge though. So if you build your whole infrastructure on client hints, be a little bit careful and do some research around it. If you want to learn more about it, Jeremy Wagner does a lot of advocacy work about this, so you can check that out. So with this, we're serving the right data. But then there's also this header, save data. And I love save data because the idea is just nice. So what browsers do is that you can send a saved data header. And then when the browser makes a request, this will be available as the header that comes in, or in JavaScript in the navigator connection safe data. And there are some websites that are already working with this kind of idea to opt in for the request of users that don't want to spend all their data. So for example, when you have a look at Twitter, they recently rolled out their progressive web app, and they have a safe data mode, which I think is a very nice idea. The thing though is that the people at Twitter do not use the standard safe data header. They just build their own thing. And this makes me very, very sad, because some browsers have the option that you go into their settings and you say, I want to run in a safe data mode. And Twitter is unfortunately not reusing this information. So I think that we should use the platform and the tools that we have instead of reinventing everything. To set a safe data header, for example, in a desktop environment, I have to install a browser extension. I think this is completely the wrong approach. It's buried into browser settings. What I'm dreaming of is this, that browsers should look like this: URL bar, and do you want to save data? Because it shouldn't matter if I'm on my browser, if I'm on a desktop computer, because I'm using my phone that is being a hotspot for my computer, right? I still want to save data. It doesn't matter if I'm on my computer or not. With this, I think that safe data should be a first-class citizen. Maybe we're getting there. Maybe not. Let's see. So I believe we should provide an easy way to save data wherever and in which environment we are. Google has also a stand on safe data. So 6 months ago, they released something that is called Chrome Light Pages. So if you want to work with this, you have to be a little bit careful and at least see what happens there. So when you enable the safe data mode in Chrome, it could be that you get an altered version that is optimized by Google. I'm not sure about how I feel about this. If you want to work around this, around Chrome Light Pages, what you can do is you can set a no transform directive. So overall, I'm really disappointed that the industry is not using this header, but then there are also moments like last week. Shopify is shipping 13% less data when someone has the safe data header set. And this is 20% of the requests coming from India or Brazil. Think of this. 20% of requests for the scale of Shopify. This is a few people, and this is a few bytes saved on the wire. I think this is great. So if you want to learn more about this, just this week there was this nice article telling how you can use it. And if you want to enable it, just make sure that you're not reducing the amount of features or experience that you offer for your users. Because a lot of people are like, no, we don't want to reduce stuff. When you're smart, you can ship low-res images. You can maybe drop this carousel that nobody cares about. You could stop shipping fonts because, let's be honest here, I'm a developer. I couldn't care less about custom fonts. People have safe data turned on for a reason. So let's have a look at real responsible dev. So when we go to /affordable, so what you see there is that I'm shipping Brotli. Oh, I cannot see this. I'm shipping Brotli for the HTML. And you see that there's this header JPEG, which is saying, I want to have a JPEG, but I'm responding with a WebP image. Because Chrome tells me, hey, I understand WebP too. And there's no additional markup needed. And you see here that the image gets smaller, depending on how wide the browser window is. Because I set client hint headers, so that the browser now tells me how wide the viewport is. There's no additional markup needed to make this work. And with this, so these are the headers that are sent by Chrome then. So with this, we can save some data on the wire, which is important because I think it is important because the web is with us every day. The internet is nothing nice to have anymore. Unfortunately, we reached this kind of state. Anyone guilty of building something like this? Maybe not that extreme, but... So it shouldn't be, the internet should not only be safe and affordable, it should also be respectful. Because nobody likes a random person approaching you on the street who's like, hey, scale 1 to 10, how did I do? I don't know you, man. What's going on? So one of the most important things for respect is time. And we should optimize our websites to get the important pieces down as quickly as possible. So what you can do is you can define a meta element with link rel preload, or you set a header, which is like link rel preload. What you can tell the browser then is to, hey browser, you don't know it yet, but you need this resource very soon. If you use the header variant, you have to be a little bit careful depending on your setup. If you have a certain CDN or proxy service before you have to define a no push directive, because some CDNs tend to use HTTP to push if you set the preload header, which right now is not considering the browser cache. So I would recommend to go with a no push setup to just make an additional request instead of using HTTP to push. This is great to speed up critical resources like fonts or the one image that is in the header or something. The support for rel preload is pretty okay-ish, so you can use that today and can speed up and optimize the resources that you want to load quickly. To save some time for the users, right? If you're loading a custom font, maybe you're blocking the rendering of fonts, which you shouldn't do, but maybe you do. When you optimize this, you can load files quicker and maybe save a second or two. And then we have also the don't annoy the user part, which I always call kind of the AMP reaction. So AMP is this project by Google, Accelerated Mobile Pages. And basically what they're doing is they're reinventing the wheel, sorta. And 2.5 years ago I was giving this talk, which went into the internals on how AMP works, because technically it's very interesting how they do it and how they achieve what they achieve. And all the standards people in the community were then like, that's not good. We should make a standard out of that. And it's very funny now because 2 years later, we have a standard, which I think is very nice. So what you see there is feature policy, and what this header or this specification allows you to define for your website what should be allowed in this site. And there's a lot of stuff that you configure. Should the browser or some third-party script be allowed to ask for my location? Well, I would be pretty clear that this shouldn't be possible in my site. So right now, we're a little bit cutting edge there, but we're getting there. And then there are also two very exciting ones. So for example, there's unoptimized images and unsized media in there. Think of this. You can set yourself rules to not load images that are not optimized, to not spend 50 cents for a person that calls your site from a certain area in the world. I think this is just very, very cool because it helps you to nail down your website and what is included in your site. So this is the feature policy header that I currently use for my stuff. Give that a try if you want to. Feature policy also works for iframes, which is a good thing because usually third parties work in iframes. And you have also access inside of JavaScript using document feature policy if you want to work around this. Because maybe you are building a product that needs camera access, right? If this is blocked, you should have a way to work around this. Watch out though, so the JS API is still a little bit, but you can just feature detect that if you want to. If you had a look at this whole list of all these options, you might have figured out that there was one missing in there, and it's probably the most annoying one. What happened to push notifications? It turned out people writing the spec for the feature policy figured out that allowing or not allowing push notifications is harder than it first looked like. So if you want to learn what's the state with push notification, you can have a look at this GitHub issue. Usually you can follow specifications and browser vendors, how they decide on certain things, and it's very interesting because you can learn things in browser internals when you have a look at these. So how's the support for feature policy today? But you can ship this header. If the browser doesn't understand it, then it doesn't understand it, and that's it. So we should respect, or we shouldn't annoy our users. So what about the privacy part, which becomes more and more important? Browsers for quite a while shipped this header that was called do not track. So you could enable this, and it was very well supported. So you could set this header, so the browser then sent a request to the HTML page, and it had do not track in it, which tells, hey, I don't want to be tracked. Cool? Cool. Then it turned out that Safari removed do not track because it was used to track people. Web development, right? So we ended up here. And overall, I feel like that do not track was unfortunately not more than a nice try. Because a lot of people make money with ads. And if they can track and if they can make money, they will do that. So where we were here. You could define do not track headers. And what is very interesting to see right now is that several browser vendors changed their settings. So for example, Firefox now has something like this. And you see there content blocking. Samsung is shipping with everything has to be AI, right? So Samsung is shipping something with AI, tracking protection, whatever. Safari is nailing down on tracking blocking. And what is happening right now, and we're pretty much in it, is that we're now in a new browser kind of war. And it's all based on privacy, which is very interesting to see. Means that do not track header is more or less over in my opinion, but let's see where this goes. So when we go to the responsible.dev/respectful, so you will see that the permission dialog is gone, and you will also see that that the image was loaded on the second place. It was actually referenced in a CSS. So the way that it usually works is that the browser references or loads CSS, and then the CSS will trigger another load. But I had defined the rel preload header, which means that, hey, load this. And later it figured out, yeah, you needed this. Cool stuff, Stefan. Overall, I think that building for the web is very, very hard. I love building for the web, but I also spend hours on the weekend reading newsletters, right, just to keep up with all these things. You have to consider design, content, performance, accessibility, frameworks, network, and devices, and there are 100 more points that you have to watch out for. How can you build good websites then? So you can use Google Lighthouse, which ships in Chrome itself. This gives you a lot of information about things that you can improve. So if you don't know that, have a look at this. This is not taking headers that much into consideration. And I want to give a massive shout out to this tool here, which is WebHint.io. This is basically the counterpart from Microsoft, and it is the most picky tool ever. I'm working months to get a green WebHint score. So have a look at this. I can highly recommend that. If you want to get a more complete overview of what is possible with headers, if security is your jam, securityheaders.com. The highest grade is A+. I have an A because I have this inline JavaScript thing. So security-wise, this has you covered. My friend Shep has this massive slide deck, which is pure information, which is HTTP headers, the hidden champions. Very good stuff. And Andrew Betts, who works on specs, has this talk that is called Headers for Hackers. Highly recommended to check that out. So I think that the web has to be safe, because it shouldn't be possible that my mother mines bitcoins accidentally. I think that the web should be affordable, because everybody, no matter where he or she or they are in the world, they should have the same access to information. And I think that the web has to be respectful, because nobody likes annoying people. So the web has to be safe, affordable, and respectful, so that it really is for everybody. Thank you very much. I'm Stefan, and I will be around. And I have stickers, if stickers are your stuff. I think I have 3 minutes for question here.